We got it. We got it working. Yes, that was a bit painful to get that sorted. First, the tablet wasn't working. Then the streaming software wasn't working. So we're good to go. All right. Look, we're gonna get straight into it. Yes, Masha tried that. Worked a couple of times. Not enjoying calculus. Oh no, that's terrible. Like, it's a great little thing. All right, so we're gonna get straight into it because we kind of like mucked around for like 6 minutes doing fixing silly things. All right, so today what we're going to be talking about is two things. All right, so the first thing we're going to be looking at is turning points, and then we're going to be looking at increasing, decreasing functions. Hey Joe, looks like we've got a few usual, the new usual suspects is coming. All right, so we're gonna get started with turning points first. Let me just grab my notes. All right, so when you think about, when we talk about curves, we've got a parabola, the two types of parabolas there, and then you've got a cubic that looks like this, or a cubic that looks like this, and then you can do x to the power of 4. I don't know what it's called, but anyway, a turning point is these points right here. So as you can see, I'm gonna put a bunch of these points. Basically, it's when the gradient, the slope actually changes. So when the slope actually goes from like, so in this side, all the gradients are negative, but after the turning point, it becomes positive. For the second curve, we've got positive here, negative here, and if you look at the cubic, we've got positive, and then we've got negative here, and then we've got positive here. So anytime, I always struggle with this because I am doing it at home. Oh yeah, cool. So when it's actually going up, it's positive, and when it's actually going down, it's negative. So if you look at the negative cubic there, we've got, so that's negative slope, positive slope, and a negative slope. And the red points right there, those red points are known as turning points. Now the key thing about turning points, so for turning points, I don't know, I just put that as TPs all the time. So for the turning points, you don't have a positive or a negative. What you do have is gradient is equal to 0. So I think in calculus, most of the time you're looking for like some sort of max or min. And what you do is you pretty much differentiate, put it equal to 0, and solve for x, because that's going to give you the turning point. Tanish, yes, it is on my list. I need to do it at some point. All right, so the first thing we're going to do is we are actually going to be, we'll do a couple of basic turning points. I mean, like, look, we're gonna go really fast in the session. By the end of it, we'll be looking at doing at least a couple of merit questions by the end of this session. And you'll be like, what? That's a merit? Yes, that is a merit. So anyway, to get started, what's the first thing is I would like you to do this. So let's actually go with question 1 straight away. And I'm gonna say calculate the coordinate. So calculate coordinate of turning point, and of the curve, I'm going to give you the curve. F of x equals 4x squared plus 16x minus 3. All right, so I would like you folks to calculate this. Now what we do is when we do this as an example, well, actually, you guys have it a go. All you got to do is you got to differentiate, put it equal to 0, find the value of x, and then once you get that, you should be able to calculate the y value as well. And in the meantime, what I'll do is I'll load up this question, 4x squared and 16x. Cool. Looks like an ugly number, but Yes, Elliot, yeah, because that's telling you that the gradient is equal to 0, so you want to put f dash of x is equal to 0. Nice. Okay, so I'm going to start doing this slowly. So we've got f of x. So f of x is equal to 4x squared plus 16x minus 3. F dash of x, we're going to differentiate this. We're going to get 8x plus 16. Now, it's important that you actually put down f dash of x equals to 0 for turning point. A statement like this is really kind of like good habits, because you want to tell the marker that you actually know what you're doing and not just blindly putting things as, you know, gradient equation equals to 0. So we've got 8x plus 16 equals to 0. So 8x is equal to minus 16, and then x is equal to minus 16 divided by 8, and we're going to get x is equal to minus 2. Now, we want the coordinate of the turning point. Because we want the coordinate of the turning point, we're going to have to go back and substitute it in the original equation. So we've got 4 times negative 2 squared plus 16 times negative 2 minus 3. So 4 and 4 is 16 minus 32 minus 3. That gives you minus 19. So the coordinate of the turning point is going to be minus 2, negative 19. Yes, Rev, it'll always equal to 0 for a turning point, because if you go back to the earlier example that I was talking about, or the notes, turning point is when the gradient changes from positive to negative. So if a number is changing from positive to negative, it has to go through 0. So that means gradient is always equal to 0 for a turning point. Now what I've done is, let me just check this is going to work or not. Alright, here we go. I actually drew this graph in Desmos, and as you can see, at negative 2, negative 19, we've actually got a turning point, because all along here, the slope is negative, and then when it comes to this turning point right here, it becomes 0, so it's like a flat line, and then after negative 2, it becomes positive. So we're going to do a couple of more examples, because I'm telling you, once you get the hang of this, increasing and decreasing functions is just super easy. No, 100 ping, you don't need to draw a graph at all. I just kind of wanted to show you guys where, or like what the what it looks like, that's all. All right, let's do one more question. I want to try this. Let me just write out the question first, because I hate giving questions that end up not working out. So we've got minus, what is it? All right, now I am going to give you a question that's kind of ugly. So they're not going to have like pretty numbers. No, that's too ugly, because geez, that's... Geez. Okay, now wait, give me 1 second. Let me just change that. No, that didn't make any sense. Plus 15. Whoa, F11. All right, give me 1 second, folks. I just want to get a nice question, that's all. Because I hate giving questions where you end up with like super nasty numbers. Let's try. Okay, let's try this question here. Number 2. It might be nasty, but so I would like you to calculate the x values. So I don't want the coordinates. X values of turning point for x cubed minus x squared minus 30x plus 72. God, I hope it works out, because if it doesn't, it's not going to be fun. But let's just, okay, you folks try that, and I'm just going to see if this minus 30. Okay, it's not too bad. Nope, still ugly numbers. That's fine. Work it out. Let's see what happens. Evening Quack. And hello, Robert. Welcome. Anonymous. No, I think these will be all achieved questions. Just give me 1 second. I just need to load up all the exam questions so I can actually get a couple of exam questions for us to do. Because that's pretty much it for turning points. But resources. 261 exams. All right, so we're starting to get some pretty ugly looking numbers. Oh no, I've opened the wrong standard. Sorry, folks. 262 is the one I'm looking for. Come on. All right, cool. So we should get some sort of nasty looking decimals. By the way, I'm going to show you folks the actual equation first. So this is what the graph actually looks like, and you can actually see the two x values that you should be getting, which is negative 2.85 and positive 3.51. Now, how we're going to do it is we are simply just going to differentiate this. So we're going to differentiate f of x. So we've got f of x as x cubed minus x squared minus 30x plus 12. So f dash of x equals 3x squared minus 2x minus 30. Now, in calculus, right, now even in algebra, when you do have a quadratic, like if you don't have a graphics calculator, then yeah, you've got to actually do this the long method. You've got to actually show like the quadratic formula and stuff like that. But when it comes to because you have the graphics calculator, all you need to do for this is you can just go straight into the equation mode. Yeah, it should have been, sorry, I think, was it a 72? Yeah, it should have been a 72. It should have been a 72, but you know what? Doesn't matter because it's going to go up anyway. It's okay. No, it wouldn't matter, folks. Sorry, that was my mistake, copy mistake. Don't worry about it. Because if I go back here, I know I did it as 12 by mistake, but if I put that as 72, it's just still going to be the same values, like the turning points. See that? It's still negative 2.85 and 3.51. The y values will change, but not the x values will still stay the same. So don't stress too much about it. So we're going to go into polynomial here. Degree unknown is 2, and then we've got 3, negative 2, and negative 30. And when we do this, we're going to get our two values. So we're going to get x is equal to 3.513 and negative 2.846. So that pretty much is all you need to do for achieved. Now what I'll do is I'm going to try and find a couple of achieved questions for us to do. It's something else. No, we already did this question yesterday. I'll answer that in a second. I'm trying to find a question that we could potentially do. Where was it? Yeah. Jeez, they don't really give like basic gradient turning point. No, they don't. I'm just looking through the old exam questions. Nope. Function. Nope. That's it. So what we might do is I might just pick up a random question for us to try and work through. What about without a graphics calculator? Elliot, without a graphics calculator, you'll have to use the quadratic formula, which is this thing right here. And you've got to actually substitute your a with 3. You got to substitute b as -2. And you got to substitute c as -30. And you've got to do the quadratic formula for this to actually work. But yeah, without the calculator, it's just, I feel that it's a waste of time. Quack to quark, especially if you're doing like three externals, you don't want to be wasting time on a question where you could potentially make a mistake, which might actually give you no grades at all, which kind of sucks. Okay, so what we're going to do now is I'm just going to divert a little bit. We still got about 5 minutes before starting increasing and decreasing functions, but I'm just trying to find like a merit question, but it looks like all the achieved questions you folks are super comfortable with. Function is given by blah blah blah. What does it say? C. All right, so let's try this question from one of the papers, and I'm sure this is an achieved question, just to kind of divert a little bit and do like an exam question, right? Yeah, Goblin King, yeah, you don't need a graphics calculator, but it does kind of make it slightly easier, I'm not gonna lie. Come on, kid. All right, just give me a second. This is just loading up the question. Here we go. All right, so like you folks to have a go at this question here. This is actually from 2021 and probably an achieved question, I think. I need to have a look. 2021. B. Oh, 2022 I'm looking at. 2021. Oh no, this question is actually a merit question. Sorry. I lied. Joe, no, you can do y instead of f of x. That's fine. Not a problem. Just like how what Quack actually said. DXX, we're just starting this, man. Like, you know, watch the first 2 episodes and come back. You'll catch up in no time by the time we finish this series. Kingston, like I won't get that paper till like end of, I think middle of next year, mate. So I won't be able to do a video for that. Like, yeah, it doesn't. They don't give the paper out till like well into next year. All right, how are we going with this question? So just differentiate it, people, and kind of follow the steps, because write down what you have and what you're looking for, and you should be good to go. Madeline, no, we just started, but like what I do is I do a couple of questions and then I do like a couple of exam questions. So just so that you know what's happening. All right, so I'll do this one. And we might do a similar question like that. Oh, actually, no, I don't want to do similar question because you guys will know how to do that, and it's just a bit of a waste of time. So in here, what it says is we've got f of x. All right, we've got f of x, which equals to 5 plus 3x plus cx squared minus 2x cubed. Now, the next thing that we know is from reading the question is the gradient at 2 is negative 5. So we can say f dash of 2 equals minus 5. So that's all it's basically saying, is that f dash of 2 is negative 5. So then what you have to do is you have to differentiate f of x to get f dash of x. So when we get f dash of x, we're going to get 5 goes into 0, 3x turns into 3, cx squared turns into 2cx, and then minus 2x cubed changes into minus 6x squared. So that's all we have, all right? And that's all we really need for this question, because all we have to do is, because we know that f dash of 2 is 5, we're just going to put down 5 is equal to 3 plus 2 times c times 5 minus 6 times 5 squared. Oh, not 5. Sorry, what am I doing? Should be 2. My bad. Sorry. This should be 5. This should be 2 and 2 squared. Cool. So the next thing is I'm just going to kind of expand this. I've got 3 plus 4c minus 6 times 4 is 24. I've got 5 equals negative 21 plus 4c. And then I've got 5. Oh, sorry, did I put negative 5? My bad. Sorry. Lots of little mistakes. Thank you. So I've got negative 5 plus 21 equals 4c. So 4c equals to 16 and c is equal to 4. Now, this question I thought was actually a achieved question, but in reality it was a merit question. So folks, look, if you are coming in here at the moment and you're like, what the hell is happening here? You know, I would recommend maybe going back to part 1 and part 2 before you come to this time, because you know this is part 3. I mean, like, you kind of have to do the first couple of parts to kind of get comfortable with this. Right, the next question I'm going to do, I'm just looking at another possible achieved question or a merit question, and it's just kind of like revising some of the stuff we've actually done before. Jamal, I don't think I did f dash of 0. I think I put f dash of x equals to 0, Jamal. So for that one, it's because I want the gradient to be equal to 0, because I'm trying to find what do you call it? I'm trying to find like where the turning point is. Give me 1 second. I just need to change something here. Okay, sorry, just it's too much spamming for me to handle the deal with this. All right, so next one we're gonna go into. It's always nice to do that. Next question. Let's try next question. Looking for another question. Or shall we just do increasing and decreasing functions? What do you guys want to do? Do another question or just go straight into increasing, decreasing? Okay, let's do increasing, decreasing, because the thing is it's not too bad. Or actually, I'll do one more, and then do increasing, decreasing. Because I think once you get the hang of it, you're pretty much good to go. All right, let's do this one here. This is another merit question. Where is part 3? Okay, next merit question coming up. So this is from 2020. What question was this? 2D? No, 3D. No, this is not a merit question. This is an achieved question, by the way. Sorry, I thought it was a merit question. JC Popham, I've done some videos just covering numeracy basics. Best thing to do is go through the exams, my friend. Like, that's all I can say. By the way, this question is an achieved. And while you're looking for it, I'll look for another question. Existence, integration. Oh, I like this one. This is a good question. But no, what I'm doing is I'm just doing questions that's related to today's topic, which is just turning points. So I kind of did a couple of examples, and then we've just been doing exam questions because much easier doing that. Gives you a bit of confidence as well. And trying to find like merit questions that has things like turning points and so on. Ooh, we got 2 different values there. Wonder what happened. Oh, we got a couple of 0.5s coming up. Nice. Okay, I'm gonna start doing this. So we've got, it has a tangent with a gradient of 15 where x equals to 2. So f dash of 2 is equal to 15. So then what happens is then we're going to go f of x is kx cubed plus 9x. Then f dash of x equals 3kx squared plus 9. Then we just substitute 15 and 2. Because f dash of 2 equals 15, we've got 15 equals 3k times 2 squared plus 9. We're going to get 15 equals 3 times 4, which is 12k plus 9. And then 12k equals 15. Take away 9. 12k equals to 6. And k is equal to 6 over 12, or 0.5. That's an achieved right there. Oh, yeah, that's gotta stink. Because then you would get 24 over 12. Yeah, now I can see how you got that too, Chai. All right, so we're going to do one more turning point question again. I'm sorry, but this is just a merit question. But like, look, the whole point of turning point questions is that they just, it's pretty much the same thing, but they just ask like different variations of it. So we'll try this one here. I'm going to try and see if I can move this along. Actually, no, wait. Before I do that, does anybody have any questions on this particular question here? Like, if you do, what I can do is I can put some line numbers, just yell out 1, 2, 3, 4, 5, 6, 7, 8. If there's any particular line you don't understand, give me a yell out. How do you know when to set to 0? All right, Zaida, the only time you'll ever need to set it to 0 is when you find the turning point. So when the gradient is equal to 0, that's the only time you need to put the gradient equal to 0. Like in this one, it's actually telling you the gradient is 15 when where x equals to 2. So this part right here tells me that f dash of 2 is equal to 15. Any other problems, or can we move on? Three, two, yeah, next plus. Good job. Next one. This one here is a merit question. This one. All right. Now, Zaida, you were asking. It's like, when do we know if it has a? When do you put it f dash of x equals to 0? I think I already told you the hint for this answer, the hint for this thing. Oh man, I can't control that now, so I need to change that setting. I remember we were having problems with when I was doing the algebra one as well. Can someone please remind me, because I need to figure out how to switch it off, because it's starting to do it automatically now, YouTube. I can delay it. I want to delay it. Create a highlight video. What the hell is this? Hey Layla, how you going? Oh, we got two different answers again. Got -2 and +2. What you guys get for K? I think that's the first thing we got to figure out. You got to figure out K. Hey, Kian. By the way, is anybody from Linfield College here in the stream today? I just got to ask. Oh, K is equal to 6. Yeah, I got 6. I got 6. K is equal to 6. Nice. Now with this question, you can figure out K is equal to 6 by doing two ways. And I'm going to show you guys both ways, just so that you can kind of figure it out. Hey Joanne, how you going? I don't know if I got to see you today or not, but yeah, I had a good time. All right, so the first method I'm going to do is this one here. I know that f of 3 equals to 4. Right, that's number one. Number two, I think Zaida, you asked me, when do I know that when I get a gradient equals to 0? Now this particular graph has a turning point at x equals to 3. So what we can then say is f dash of 3 equals to 0 because it has a turning point. Ah, nice, Joanne, nice. So then what we can do is we can actually do it two ways, right? Because the first thing is, because f of 3 is 4, we can actually put this in the original equation as -3 squared plus k times 3 minus 5. So we've got 4 equals -9 minus 5 plus 3k. I've done something wrong, haven't I? Have I done something wrong? -14 plus 3k, rearranging it, I'm going to get 4 plus 14 is 3k, 18 is 3k, and k is equal to 3. That's one way of doing it. The other way of doing it is f dash. So I can actually go f dash of x equals -2x plus k. And because f dash of 3 is equal to 0, I can put in 0 equals -2 times 3 plus k. So 0 is equal to minus 6 plus k, and then k is equal to positive 6. Yep, I realized what my mistake was. It's 18 over 3. So as you can see, there's two ways in which you can do this. All right, so you could have actually done it with the f of 3, or you could have actually done it as f dash of 3. So either way you do it, you're going to get the same value for k. Now the question's asking find the gradient where x equals to 4. So we want to find out, well, first off, we know that f dash of x is equal to negative 2x plus 6. So f dash of 4 will be negative 2 times 4 plus 6, which is negative 8 plus 6, which equals to negative 2. Now, it's a great question. You're wondering which one is better. To be honest, you will have to differentiate, right? So because you have to differentiate, I would probably be going with the I'd probably be doing this first and then going with this one, because because I know that I have to differentiate for the second part. I might as well do it and just try and solve. But that's assuming they said the turning point. If they didn't say that there was a turning point, then you wouldn't be able to do the working in the green box. The only reason you could do that was because they said it had a turning point. But if they said something like the curve goes through this point here, then you have to use the yellow the method in the yellow box. What if they give you y and not x? Hang on, give me 1 second. Let me just... No, I've just... Stupid thing, delay ads. Yeah. What if they give you y and not x? Well, how would that work? Trying to think how would that work. Master, I think the way you're asking me that question, you're putting me on the spot here, but I don't... They will have to give you all the details that's necessary for you to solve the question. They won't just throw you in the deep end and be like, hey, go and do this and see what happens. Like, I'm trying to think, how would you do that? Somehow they'll give you a way to try and figure out. Somehow they'll give you a way to try and figure out the values. Now, Master, look, it's a fair question, but to be honest, a lot of people feel that calculus is actually a lot more easier than algebra, because it's like, it is quite straightforward after you do like a whole bunch of questions. How did you get f of 3 equals 4 in the yellow box? Now, Ravi, when we have this right here, notice how when it says 3 and 4, this is the same thing as saying x and y. So basically what that's telling you is that if I put 3 in this equation, I am going to get a y value of 4. That's all that means, Ravi. All right, guys, look, increasing, decreasing, we're going to do it real quickly because the last time I saw an increasing question was in 2019. Unless I can't remember the 2023 paper, whether there was an increasing, decreasing function. I'm just going to have a quick look at it. Passes through. Oh, yeah, true. Last year was an excellence question. Okay, cool. So with increasing and decreasing function, all you need to know is this right here. We're going to go back to this right at the start of the tutorial. How do I say this? To find an increasing or decreasing function, I'm going to highlight this. Everything that's actually positive, it's what we call increasing, like the function is increasing. Because if you think about it, along this yellow line, the gradient is positive. And if you look at a cubic, it's positive up to here, and then positive after the turning point. And if you look at the negative cubic, it is positive between those two turning points. If we want to look at decreasing, when it's decreasing, the slope is actually pointed downwards. So it's actually looking like this. It's decreasing when the gradient is actually negative. So from here to here, it's negative. From here to the turning point, negative. After this turning point, it is also negative. So pretty much all you need to know about increasing and decreasing functions is this: increasing, going up; decreasing, going down. That's all you need to know. And usually they ask you questions like with a cubic. Last year they actually had a x to the power of 4 graph. So to combat that, I'm going to give you a bit of a little hack. Well, not a hack, it's more like this is what it ends up looking like. So when we have the equation like x, which is a straight line, it's going to be fully increasing or fully decreasing. Then you'll have something like x squared, where you'll have a minimum point or a maximum point. Things are increasing here and it's decreasing here after the turning point. Sorry, I need to put the turning point in red. Then what you might have is you might have an x cubed. Now with x cubed, you've got two shapes that could potentially happen. One, where the graph looks like this, or the negative x cubed, which looks something like this. Oh yes, definitely, Elliot. Don't even worry about that. We will definitely do a sketching the graph one. But this is just me just kind of going through some ideas here. Oh, it's terrible. I can't even draw a cubic properly. There we go. That's better. Now, when it comes to x to the power of 4, it'll look something like a w. All right, or something like this. And then when it comes to, sorry, that should be x to the power of 4. And if you get like x to the power of 5, it will look exactly like a cubic but twice. So 1, 2, 3, like something like that. And then same with the negative version of it. Something like this. So my suggestion for you folks is that you try and kind of remember how these shapes kind of work. All right, and if you do remember this shape, then finding increasing and decreasing functions become really, really easy. So we're going to start off with just one little question here. So we're going to do this, and I'll actually do this with you. So let's go with something like y is equal to x cubed minus 3x squared plus 9x plus 11. All right. So what I'd like you to do first is I would like you to find the two turning points. So this is what you need to do with anytime you want to do increasing, decreasing functions. Rep to Blazer, I'd like to argue against that comment because last year they actually gave x to the power of 4. That's what we thought. We thought they wouldn't give anything past x cubed, but yeah, basically that's what they did right there. So what do you know? So yeah, unfortunate for you, mate. But anyway, look, if you guys could just get the turning points, and then from the turning points, I will show you how you can actually write an increasing, decreasing function. And then after that, we'll actually do an excellence question. Yeah, you heard me right. We go straight into excellence questions. Because trust me, you know how to do this. Because once you find the turning points, you're pretty much good to go. Once you find the two turning points, give me a yell out, and then I'll show you folks what to do next. Yep, Jaden, just find the turning points first. And then once you find the turning points, let me know, and then we'll actually go from there. I'm good, Vanch, I'm good. Really? No turning points? No, there's got to be turning points, Goblin. It's a cubic. It's going to have two turning points at least. Did I copy the question wrong? Yes, I did. Sorry. I copied the question wrong. My mistake. That should have been a minus. Sorry. Rookie mistake. Yeah. Nah, you guys are absolutely right. Sorry, folks. I forgot the minus. That should be a minus right here, not a positive. I copied the question wrong. James just doing a lot of mistakes. Yeah, thanks, Shrav. Welcome aboard. Yeah, you're right, Chai. It doesn't factorize. Apologies. Damn, this is what happens when you do these stupid questions and copy it wrong. For a cubic, you should get potentially well, you will definitely get 2 turning points. You can get 1, but that's usually called a point of inflection, which we'll talk about later. Elliot, what you need to do is differentiate, put it equal to 0, and you'll get your 2 turning points. I knew I made a mistake with that. X cubed minus 3x squared. All right, here we go. Okay, so I'm assuming that people are starting to get the 3 and -1, which is really good. Bun, make sure you don't write it like that, please, because that's actually telling me that x equals to 1 and y equals to -3. Shravadab, it's been good. I went to Linfield College today. That was good fun. All right, so this question here. How do we find this, whether it's increasing or decreasing? Step 1, you find the turning points. So I am going to do f dash of x. So f dash of x equals 3x squared minus 6x minus 9. I've got to put this equal to 0. So I've got 3x squared minus 6x minus 9. Just because I know this is going to happen, I'm going to make this x squared minus 2x minus 3. 0 is equal to 3, x minus 3x plus 1. Therefore, x is equal to positive 3 and -1. Joy, you don't need to worry about getting the y values, because for increasing and decreasing functions, you only need the 2 turning points. Okay, so here's what happens. Watch this. There's 2 ways to do this, all right? The first way to do this is, and I've kind of done this using graphs, because using graphs means that you can actually get this really quickly. So what I generally do is, like, I look at this, just this thing here. I don't look at anything else for this particular graph. I look at the coefficient of the highest power. So in this case, it's a positive x cubed, which means the graph is going to look like this. Okay, I don't care, you know, the type, how it looks. It's just I know that it's going to get a shape like this. It's a cubic. Next thing I know is I've got 2 turning points. My first turning point is going to be the smallest one, which is -1. I might actually do something like this. Then my second turning point is positive 3. For this particular one, the question is asking, you know, for what, like, where is it increasing and where is it decreasing? I'm kind of doing 2 things at the same time here. Now, I do know that it's decreasing. If they ask this question, for decreasing, I would say it's between -1. So x is between -1 and 3. So this is the decreasing part of it. For the increasing part of it, I have it between these 2 values. So for increasing, I can say when x is less than -1 and when x is greater than 3. That's for the increasing part. Chai, yes, no, -1 would be the maximum and 3 would be the minimum. but I would actually do it. I will show you guys how to do the minimum and maximum next time. But this is pretty much all you need to do for increasing and decreasing. Now, what I'll do is I'll show you guys in Desmos. So if you have a look here, I have got the graph here. And again, it's just a rough shape. I just want the rough shape and I'm good to go. Because anything before -1, the gradient is actually increasing. Anything between -1 and 3, the gradient is decreasing because it's going down. And after 3, the gradient is increasing again. And that's pretty much what I've done here in the colored zone here. All right, let's have a look. Lots of questions here. Hang on. Sir, can you tell whether it's increasing by just plugging the x into the original value and seeing the y value? No, Vishal, because that's going to take you quite a bit of time. What would help you is the gradient, not the y value. If you plug it into the gradient function, and if it's positive, then you know it's increasing, and if it's negative, then you know it's decreasing. So if we try to find turning points, we always set the equation to 0. Joe, yes, that's correct. Elliot, we just did a quick factorization. Alternatively, you can put it in the graphics calculator to get your 2 solutions as well. Jaden, I did say to you, this question is an excellence. At least, as far as I know, it's been an excellence question. Left x coordinate is negative. No, Chai. We always look at the slope. We're always looking at what's happening after -1. After -1, the gradient is going down, and because it's going down, it will be decreasing. Okay, level 3 when? Oh, that's a lovely question, Tanmay. I don't know what that means. Anonymous, no, this is an excellence question. Do we need to prove it by putting a number larger than 3 and smaller? No, you wouldn't need to if you draw the graph. Matt, that's the shortcut way of doing it. That's why I like doing the graph. Can you also write it as -1? No, you can't write it like Bella, you cannot write it like that, because that's actually telling me that you're looking for, that's the wrong, the arrows are pointed wrong. What you're saying is that I want my number to be less than -1 and also greater than 3, which doesn't make sense. It's not possible for you to do that. So my suggestion is, like, if you are kind of like struggling to write the zones, I always do it like this. Let's see, I need a different colored pen here. I put the value here, which is -1. I put the 3 there, but the arrow is always facing to the pointy end is always pointing towards the left side. As for the last one, you could also have written it like this, which is still this kind of like the same way of writing it as well. So Bella, you need to make sure you write it the right way. System merit, no, already answered that. Excellence, guys, excellence. This question's excellence. Do we have to write that last bit or just get x equals 3 and -1? Master, if you put just x equals 3 and -1, the maximum grade you'll get is a merit. You have to write the last part to get an excellence. So this is one of my favorite excellence questions to do, because it literally is the easiest one. Shrav, I've done all of the level 3 15-hour playlist. Right, so to counteract the drawing the graph method, let me just pull up the 2023 schedule. Where is it? Because I was really surprised by this as well. God, it's so tiny. So this was one of the increasing, decreasing questions. And in the exam schedule, where is it? Here we go. Justifications for regions where the function is increasing. Justification includes f double dash, checking gradients, or graph of function or similar. So whoever that is that was asked, where was it? Somebody asked me that question. Jules, in the last paper, they actually said it was okay to do it as a graph. No, VDTTA, you don't need to do both decreasing and increasing. What we're going to do is we're going to do one excellence question from a few years back. And trust me, we're going to be done in like 5 minutes. So, Saida, yes, it's all done. Let me just grab this question. Which one was it? And I will give you some shortcuts for this as well. Okay, this next question is popping up. This is excellence question from 2019, I think, or 2020. Which one was it? Oh, this is not 2019, I lie. This is from a very old excellence question. All right, let's try this one here. Master, I don't know if it's a cooking good or a cooking bad, but if you ever get a decreasing, increasing function, you guys should be able to nail that real quickly. Reptoblazer, no, on and off. I've seen it on and off. Rev, I would always show the working, because anytime you write answers straight from the calculator, you're almost guaranteed you're not going to get the grades for it. Well, Jules, if they ask you to justify it with calculus methods, I will show you a little trick. Because, so one more thing you can do is you can always do this. For increasing function, you can actually write a statement like this. The gradient has to be positive. And for decreasing function, the gradient has to be negative. So you always put that, you know how we did that quadratic in the previous question when we put it equal to 0? So instead of putting it equal to 0, you just put it to greater than 0 or less than 0, and then you can actually draw the graph as well. Yeah, I'm looking for the right zone there, Bun. You have to get the right zone, otherwise you've just lost an easy excellence question. It's good to hear, Master. It's a cooking good. So remember, folks, the first thing you want to do is you want to find the grade g of x, g dash of x. So we're going to go g dash of x equals 3 times 2x squared over 3 plus 3 times 2x over 2 minus 20. So we got g dash of x is 2x squared plus 3x minus 20. Is this what we've got? So now here's the trick, Jules, that you wanted to know. Because we're doing decreasing function, you just have to do this part here. Just write a statement. Decreasing means g dash of x is less than 0. So you just go 2x squared plus 3x minus 20 is less than 0. All right, but then we got to find the x values anyway. So we're going to go into the calculator. And we're going to punch in these values. So we got 2, 3, and minus 20. And so there's our two values. We've got, so what I do is like, so kind of a couple of cheeky little things that we can do. I do this, 2x squared plus 3x minus 20 is equal to 0. So factorizing this, I'm going to get x is equal to 2.5 and negative 4. Now, the thing is, there's two ways you can do this, right? Like, and I'm just looking at Jules here because Jules has got a very good point. Doing the graph is just not enough. But the other way you could do this, I know, and I'm going to show you both methods, right? And it's good for you folks to know both methods. First is this one right here. This is a positive cubic. If it's a positive cubic, it's going to look like this. And our points are -4 and 2.5. And if it's decreasing, it's going to decrease from here to here. So straight away, you can see that the answer is -4, x, and 2.5. Now, Jules, you've been asking about, I need to show this extra bit of working. Well, you can, because the other thing you can do is from this line here, this happens to be a positive parabola. So the parabola is going to look like this. And we're going to just put because it's less than 0, we're going to put a little line like this. And these 2 points here is -4 and 2.5. Now, the question is actually saying, when is this parabola less than 0? So parabola less than 0, it's less than 0 here, because the blue line is 0, and less than 0 is between -4 and 2.5. So this is another way you could actually write this answer as well. All right, so looking at the comments here, therefore value, Jaden, you've got to get the symbols in the right way, my friend. Oliver, this is definitely excellence. Chai, don't worry, trust me. When we get to the shapes part of it, you'll find it easy. So Zaida, I think what I've done is in my old calculus live tutorials. Let me show you. By the way, that's all us for today. Sorry, that was the last question I wanted to do. But basically, if you go under, where is it? Here. Lots of stuff there. I've done questions based on themes. So I don't know what this theme is. We might have to have a quick look at it. Sometimes I write down what it is, and sometimes I just, here we go. For what value is increasing, decreasing?
Then 0 is probably an achieved.
Yeah, so here you go. This particular tutorial on 24th September, we were doing questions purely based on increasing, decreasing functions. Here we go. Heaps of questions there. Oh no, did something else as well. Oops, sorry, I lied. So yeah, there is questions there that I've done before. Ravi, no, you can actually do that. Masha, how are you feeling? Did you feel like you got that question right? Yeah, no, Rev, look, we're only up to session 3, man. We've got another 12 more sessions to go. By the end of this cycle, I know your mocks might have gone, but don't worry, because by the end of the year, you guys will be sweet with this. Yes, Smashy, there is a sketching gradient functions in that live tutorials that I shared. It's somewhere there. I just can't remember where. Chai, I'll be back on Sunday. Systems of equations is easy, master. Okay, when's the next stream? Sunday. I'll see you folks on Sunday. Yes, they all got that CS. What am I covering for the next live? Good question. Okay, let me just have a look. We did increasing and decreasing functions. What's the next one? Oh, we do maximum and minimum points. I'm going to give you a hack for that as well. It's a year 13 hack. We'll do maximum and minimum points, and then we'll do some word questions actually, application questions, which should help you out with that. And then we go to integration by the looks of it. So yeah, people, that's me done today. I think I missed a whole lot of questions there. Sorry. Elliot, is there any solution how to solve an equation equals 0 with more than one x variable? No, I'm not sure I understand your question, Elliot. Sky, we're doing maximum and minimum next, so all good. We'll see you Sunday. My students call me Subhash, Ravi, because in my school they call me by my first name. Yep. Have a good night, team. I will see you Sunday for the rest, next part, which is maximum minimum. I get a feeling we might actually be done in 10 hours at this current rate. I don't think we're going to need 15 hours. I thought we need 15 hours, but to be honest, we're gonna fly through this at this current rate. That's all good. All right, people, take care. I will see you Sunday. All right. Till then, look after yourselves. And oh, one more thing before I go. Before you go. What are we up to? What are we up to the channel? We are up to, let's see, YouTube Studio. 49. Ooh, we're near up to 49.4. Looks like the 50K is not very far away. Catch you later, folks. Take care. And if any of you from Linfield that's still hanging around in the stream, thank you for today. It was awesome. I really appreciated it. I actually loved all of the presents because that was not supposed to happen. Got this from Carmel College. Got a whole lot of messages that I got to read through. Still got to read through all of my Oriwa College messages. Basically keeping them safe because it's like if I ever have a bad day, I kind of read through. And I got this today too. Thanks to the lovely person from Linfield that actually made this for me, which was really awesome. I'm gonna keep it here. Got a whole lot of stuff. I need like a decorate this area. All right. No, that's it. Cool. Done. Enough showing stuff. Go to bed. I'll see you guys on Sunday. All right. Take care. Bye.